In this video, I'll go through some of the basic aspects of water storage tanks. So we can see a figure here. This is the typical layout of the storage tank. We have a supply from here, from this line, and we store the water in the storage tank, and for the supply to the residential or industries, we have another pipe going out from the storage tank. And there is another overflow if there is overflow from the tank. So basically the layout is quite simple, and this storage tank is uh, normally located at the highest elevation in the area. Otherwise it has to be elevated, because the purpose of the storage tank is to provide the community sufficient water through the gravity if possible. Okay, so to provide water through gravity, then it has to be either elevated if there is no topography to put the storage tank at the higher elevation, or if that is available, then you put this at the higher elevation in the area. Now, what are the things you need to consider when you design the storage? So there are basically two conflicting interests. One is from the operational aspect, and the other one is from the water quality aspect. From operational aspect, we want to maximize the storage size, because we know the basic role of storage is to provide water supply, provide water during the failures and during the emergency. So bigger the storage volume, more reliable the system will be, and less chance the system would be running out of the water. So from the operational perspective, we want large size of storage, whereas from water quality perspective, having large size is not good. We want to minimize the storage volume because of the connection between the storage volume and water age. So larger the storage volume, more will be the water age, and if the water age is higher, then the water will turn bad. Okay, and it has like disinfection byproduct formation if the water stays there for long, and also loss of residual disinfectant. If the water stays in the storage tank for long, then it will lose the residual disinfectant, which it should reach up to the consumer's point. So we need to balance these two aspects, the from the operational point of view and also from the water quality point of view. Now this is a typical overview, the division of the different storage within the water storage system. So this is not the actual compartments, but the whole storage tank can be divided in these different parts. So this bottom one is the dead storage. You don't get any water from that. So water from below this point you don't use to supply. Okay, so this is called dead storage. This volume of water is used for fire suppression. Okay, so that is for fire suppression during the event of fire. Third one is called the standby storage. Then there is another one which is called equalizing storage, and the last one is operational storage. So combination of all these gives us the total storage volume required. So we just calculate what is the operational storage required, what is the equalizing storage, what is the storage for standby, fire requirement, and finally dead storage, and we sum them up to get the total storage volume. Okay, so let's talk about these different storages. The operational storage supplies the water when the pumps supplying the reservoir are in off status. So when the pumps are not working, then you need to supply the water from that operational storage. So it is likely the pumps will not work for all the time, and during that time you need to supply water from this section. The next part is the equalizing storage, and we know the water comes from the treatment plant, and for the quality perspective, to maintain the good quality of treatment, and also for the capacity of the treatment plant, normally the water coming out from the treatment plant is constant. Okay, so water coming out from the treatment plant is of the constant volume, and but the water demand is not constant, it is variable. So at the individual household levels, we use water at different quantity at different times, especially in the morning and afternoon. We use most of the water for the residential purpose. So we have the constant supply of water, but fluctuating demand, and to balance this, we need this equalizing storage. If we plot the usage of water for 24 hours, we'll see this is the period when we have higher demand, and this is the period where we have the lower demand. So during the period of lower than average demand, we fill the storage, and during the period of demand which is higher than average daily demand, we use the water from storage. And that is the function of the equalizing storage, to balance the demand from constant supply. How we calculate the volume of equalizing storage? For example, let's say you have these 24 hours and you have different demand factors. So first hour, you just need 0.55 times of the average peak factor, then second hour 0.35, and then you just start to use more water in the morning, and peak happens at 12, and again at 20th hour. Okay, so this is a typical demand fluctuation at one location, and the average peak factor is always 1, right? And then from this we can find out how much um, volume of water is being stored. So when the demand is 0.55 only, that means we can store 0.45, the remaining, in the storage. When the demand is 0.35, we can store 0.65, and when the demand is more than 1, more than the average, then we can use the water from the storage, which is minus 0.15. So negative means we are using water from the storage tank. So this way we can find out when we have excess supply and when we have excess demand. And if you add them up, you can see what is the storage we have. So initially we have 0.45 storage, and then storage of 2 hours, 0.45 plus 0.65, 1.1, and then it keeps on adding until this point. And from this point is the maximum, and then from that point we have more demand. So we are using whatever we have stored before, and then you can see the water volume in the storage tank starts to deplete, and eventually it goes to negative, right? And that this gives us what is the volume of water we need. So from highest to the lowest gives us the volume needed, which is 4.9. Okay, so that's the difference between 4.6 and 0.3, and that gives us 4.9. So we need 4.9 times the average hourly flow as equalizing storage. So which is about for 24, because we are assuming just 1 as the peak factor. So 4.9 times divided by 24 is the 20%. So as a rule of thumb, the storage volume is about 20 to 30%. Now let's go to the emergency storage. Water system intend storage volume to provide continued water supply during the abnormal operating conditions, such as a different kind of failure, such as structural failure, electrical failure, and so on. So in that case, we need to have some emergency storage, and that emergency storage is the standby storage. Now, how much storage is required? It depends on uh, the the reliability required from the governing bodies. Okay, so that it depends on the uh, consumers' expectation and their ability to pay for that. So because you can have large emergency storage, but at the same time it also costs when you are building that storage. It is you need to pay for that. So that is again the balance of the reliability of the supply system and the expenses required to have that reliability. We know the fire suppression storage for the firefighting purpose. We need to have some water, and that is defined by the local fire authority and the councils. For example, in residential area in Queensland, we have like 15 liter per second for 2 hours. So that is the fire requirement. And their storage normally you put 10%. Okay, so all these you add up.